Hello everybody, welcome to the ELM-4702 Senior Project Presentations. My name is Timothy Revior, and I'll be talking to you today about my project, the wireless security system. So a brief overview of what I'll be talking to you about today is I'll start off with a brief introduction. I'll go into the components of my system, for example, the motion, video, the outputs of the system. And since it's a wireless system, I want to implement some type of battery level indicator, and then the wireless communications throughout the system. Then I'm going to talk about how this whole system comes together in a system level diagram. I'll then talk about the user interface and how they interact with the different modes of the system. Then I'll talk about the operation of the system, as if you receive a box, how would you set this up? And then I'll talk about the timeline I projected to complete this project, then the expenses and the bill of materials, and then I'll end with the conclusion and open up the floor for any questions. So way back in December, we were given this task to design an electromechanical or electronic device in nature that would solve a problem or that could be used in everyday life. So around the time we were given this project, there were a lot of break-ins around where I live. So I thought, hey, why not make a security system? But I didn't want to make some plain old security system where they have wires running all around your house. So I thought, what could I do to spice this up a little bit? So I thought, hey, everything's going wireless these days. Why not make a wireless security system? So I began by thinking about what are the components of a security system. So for starters, you have a door sensor, which basically senses motion as someone comes in and out of your house. You then have a camera monitoring your room that's usually recording 24/7. Then you have alarms and lights that will be tripped when one of your door sensors is triggered. So I wanted to incorporate all this, and I wanted to add a wireless component. And since it's wireless, I wanted to implement some battery level indicator. And I also wanted to implement an alternative way of recording, because recording 24/7 kind of eats up your data storage. I also wanted to implement a more user-friendly interface rather than just a little box up on the wall that you have to interact with. So my first component is motion. And I take care of motion with a passive infrared or a PIR motion sensor. So what this does is it measures the infrared levels or the thermal radiation in the environment. So if I point it in this direction and someone walks through here, it'll detect a change in the thermal radiation in the environment, and from that it will emit a high signal. So the next component is video. And I did this with a standard webcam, mainly because it's compatible with LabVIEW. At the beginning of the project, I originally started with a wireless camera, but over the course of the project, I figured out that the wireless camera was not compatible with my microcontroller or my reel that I was using. So I had to default to using a standard webcam that you plug directly into the myReel. I used the camera to implement computer vision and recording. So computer vision is a method for acquiring, analyzing, processing, and understanding images and producing numeric or symbolic data from that analysis. So the way cameras work is they take pictures very, very fast. That's why they look like a continuous motion. So what I did is I take one picture, store it, let the camera take several more pictures, then I take that picture and compare it to the original, and I detect if there's a change in the pixels. So if someone walks into the camera, I can detect that there's a difference in the pixels, and from that I can output a high signal that, oh, some motion is detected. I also use this to implement recording, so every time it detects a change in the pixels, it will emit a high signal, and I'll turn on recording for, say, 10 seconds or so. Next component is the outputs of the system. I implemented lights and a speaker. So the myReel that I'm using has the ability to output 5-volt digital outputs, and as we all know, that's not enough to turn on a regular light bulb. So the way I implemented this is I had the myReel sending a signal to a relay, which would then close the circuit for the light to turn on. Another feature of the myReel is that it has the ability to produce pulse width modulated signals, or PWMs. These can be directly fed into a speaker, which will then create a sound from the frequency, from different frequencies of PWMs, or you could implement a system like lights and have it turn on a sound system around your house. So, since this is a wireless system, I wanted to implement a battery level indicator. The first battery level indicator that I designed drew too much current, so I had to scrap that design this. It's a simpler design than I originally had, and I chose this over the other one because it has a low current draw. So less current equals longer battery life. So the LED will illuminate around 7.4 volts. I'm using a 9-volt battery pack. So for a 9-volt battery pack to be considered dead, it has to drop down to 7 volts. So I have the LED illuminate at 7.4 to give the user a little heads up saying, hey, the battery's low, they need to be changed. So the next is the wireless communications throughout the system. So I did this with radio frequency, or RF modules. I used the 315 megahertz and the 433 megahertz modules. I use these two frequencies because they allow for a separate network. So I can put one sensor over here, another sensor over there, and if this sensor gets tripped, I can tell exactly where the activity is. In a standard security system, they don't have that functionality. So if someone walks in a door, the whole house goes off. You don't know where the activity is coming from. But now with a separate network, you can tell exactly where someone has entered your house. I also picked the RF modules because they have sufficient range. In OpenView, they have a transmission range of about 500 feet, which correlates down back to about 100 feet indoors. But I've used this around my house from one corner to the other, and they work fine with no problems. So the next communication part is the MyRio. So the RF modules will communicate back to MyRio. Another feature of the MyRio is that it creates its own Wi-Fi. So you can deploy the MyRio in a separate room, since the webcam has to be plugged into it. And then you can connect to it through your computer from a different room. So you don't have to be constantly plugged into the MyRio. And as you can see here, I have the RF modules feeding directly into MyRio, and this is the relay I use to implement the lights. So this is how the whole system works. So I have the PIR motion sensor transmitting its status into the RF transmitter, which then sends its data to the RF receiver, which transmits its data into the MyRio. While this is happening, the webcam is always sending data into the MyRio. The MyRio collects that data, sends it over the Wi-Fi to the computer, which I have a LabVIEW program running. The LabVIEW program will then acquire the data, manipulate the data, and send data back to the MyRio. And based off that data, the MyRio will either turn on the lights or the speakers based off the user preferences. So how will the user interact with the system? Usually in a standard security system, they have a little box on the wall, but this wireless security system, I implemented a computer interface. So we have here instructions on how to get the VI up and running. We have this remote IP address, which just allows you to connect to the MyRio. We have this file path where the user can specifically define where they want the videos to be recorded to. You have the different modes, and then you have the status of the sensors, and we have a camera display. So the camera is displaying information 24/7, but it only records when it's tripped. So if someone were to walk through this garage, it would turn on for 10 seconds, turn off, and if they're still moving around the garage, it would turn back on and back off, and so on and so forth. So as I said before, there's two different modes. There's an arm mode and a disarm mode. In the arm mode, the status of the sensors will be displayed, the camera will be activated, and the outputs will be enabled. So if someone walks past one of your door sensors, the lights and speakers will come on depending on what the user chooses. In the disarm mode, the status of the sensors is still displayed, the camera is still activated, but the outputs are disabled. So this is for more when you're at home and you're going in and out of your house, you don't want the system to be tripping every time you walk in and out. And if at any time a sensor is triggered, all you have to do to acknowledge it is hit the OK button. So if the user receives this in a box, how are they going to use it? So first, you install the sensors in your location. So you can install a sensor at this door, a sensor at that door, and you can install the camera with the MyRio in a whole separate room to monitor that room by itself. You then plug the MyRio into power and run the LabVIEW program on your computer. Then press arm and disarm to enable or disable the system. The indicators will display the status of the motion sensors, and based off of the user arm or disarm the system, the alarms will be triggered once the sensor has been tripped. So this was the projected timeline I made back in December of how I thought this project was going to go. And as shown in the red and black stripe, this is how it actually went. It went pretty well according to plan, except for the actual design and the coding. So the design went a little longer because, as I said before, the battery level indicator that I originally had drew too much current, so I spent some time developing a different one. And the LabVIEW coding went a little longer because at first I wasn't going to implement recording, but because I didn't know LabVIEW could handle that. But after I learned out that LabVIEW supported it, I worked and tried to implement recording before the project was due. So the bill of materials comes out to about $380, and that's everything that's on this table right here. So what I've only purchased is around $130 because the MyRio takes up a huge chunk. It's $250. So if you subtract that, I only spent $130 this semester on the project. So the design elements I wanted to implement from other classes I've had are my LabVIEW class. I did that by using the LabVIEW program. I wanted to implement lessons from data and communications, which I used creating a wireless network with the RF modules and the Wi-Fi of the MyRio. I wanted to implement my electronics class by building my own battery level indicator. And I wanted to implement sensors and instrumentations by using the PIR motion sensor. So if I had more time to work on this project, I would have more sensors. So right now I have 2 motion sensors and a camera. I would like to add at least 3 more motion sensors and at least 1 more camera, so you can cover like the doors in your house and the windows, and you can have 2 rooms monitored. And this would essentially call for a wider network. So I'd just like to thank Mr. Michael Marceau for leading the class, Peter Cassavant for keeping the lab up and running and ordering our parts for us, my classmates for their input on when I got stuck on problems throughout the project, and then the National Instruments website for helping me with the LabVIEW program. So at this time, I'd like to do a quick demo. So right now, the user has put it in the disarm mode. So I can go by these sensors and nothing will be tripped. And if you can see the camera, it's pointed that way. You move your hand through it, and it also gets tripped. So now the camera is recording. So now, with the lights on, past the motion sensor, the light will come on. It'll stay on for 10 seconds. It's kind of like a garage light where you walk through it, it comes on. If there's no motion for a certain amount of time, it'll turn off. So in a certain amount of time, this will turn off. And then see the sensors are still red, but if it still gets tripped again, the light will come back on. So now the speaker and the lights are enabled. So if you go past the sensor, the speaker I'm using is just for demonstration purposes. You can hook this up to a louder speaker system in your home, implementing the relay idea I did with the lights. and that's the wireless security system.